Today we're going to talk about the Grignard reaction. So this reaction is a really important one that's taught in Organic Chemistry 1 classes. This requires an organometallic species, which we'll introduce in the mechanism part of this presentation. This is the first example of a carbon nucleophile that we'll explore, and that carbon nucleophile allows us to create carbon-carbon bonds. So a typical reaction first involves the creation of the Grignard reagent. So we have some kind of alkyl halide, which I'm showing here as just RBr. This is treated with magnesium metal, magnesium 0, that is, in the presence of diethyl ether, a somewhat polar aprotic solvent. And then this creates what's known as the Grignard reagents. And I like to show a resonance form that highlights the nucleophilicity of this R group. So when we show the organometallic compound like this, we call it an organometallic because it has, well, an organic part, that's the R, and a metallic, which is the magnesium bromide. A resonance form you could draw is putting these two electrons onto the R. And this, and effectively breaking the carbon magnesium bond. When you do that, it's really clear that then the R negative has a nucleophilic character. But we usually don't draw this as R minus in any kind of mechanism. So let me show you an example of a reaction that could happen with a Grignard reagent. So this is called methyl Grignard. So we have the methyl group attached to the magnesium bromide. And when we react this in the presence of acetone, followed by hydrochloric acid, you end up with a compound that looks like this. Okay, you now have a tertiary alcohol, terbutanol, in fact. So let's look at the mechanism. So we imagine these two electrons attacking the most electrophilic part of the acetone, which is the carbon terminus of that ketone. We break the carbon-oxygen pi bonds, and we create this intermediate. Okay. And in the second step, this gets protonated by the hydrochloric acid. To make the product. Now, it's extremely important to realize that the Grignard reagents cannot be added at the same time as hydrochloric acid or even water. Really, anything that has freely accessible protons will destroy the Grignard reagent itself and just, in this case, create methane. It just will protonate the Grignard reagent itself, thus blocking the carbon-carbon bonds that you probably seek to form. And to take this a bit further, this Grignard reagent will even react with water that's in the air in normal water vapor, what contributes to relative humidity, what contributes to the humidity in the atmosphere. So these are known as pyrophoric in the sense that they will actually create fires. And this is a somewhat common feature of organometallic species in general. So organolithium species, which you might learn about in your classes, are also extremely pyrophoric and probably aren't going to be included in your lab classes. And here's some questions to ask in office hour. One, why are Grignard reagents less pyrophoric than organolithium reagents? And two, what is the mechanism for the reaction of Grignards with water or hydrochloric acid? Well, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.